PreCalc 1.7 combinations of functions and composite functions. All right, a lot of function notation here. This is what we have to keep in mind and how we work with them with composite functions or combining functions together. One of the big key things we want to make sure we talk about throughout this is a function's domain, because as you combine functions or do a composite of functions, the domain will have a strong impact here, or the impact on the composition. So we need to make sure we know what our domains are, okay? So first, let's just talk about finding a function's domain. Now, if you're not modeling data or real-world conditions or whatever, you usually have a domain of all real numbers, negative infinity to infinity as the interval, okay? Obviously, with real-world data, a lot of times you don't have the decimals, the points in between, because you have to have a full whole number of some kind of something. So that's a completely different idea, and we're not going to really worry about those right now. But for the domain, if you can't be all real numbers, there's some red flags, basically, that's what I like to call them, that I watch for. One of them is you can't divide by 0, okay? So if we have a denominator, we have to make sure our denominator does not equal 0. The other one is if we happen to have an even root, okay? So a square root, a fourth root, sixth root, whatever that might be. If we happen to have an even root, we cannot have a negative inside that, okay? So those are our two big red flags that we're going to watch for today at least, okay? Is anything that would make the denominator equal 0 and anything that would make a negative value underneath a square root or even roots. Okay, so for number 1 here, it says find the domain of the function. So I have this function, I have two fractions. I'm going to be honest, I'm not going to worry about getting them to a common denominator or anything like that. I'm just going to work on looking at my denominator, saying what would make this equal 0. So the first one I get is x squared plus 1. It cannot equal 0, okay? So if I subtract 1, I'll get x squared is not equal to negative 1. Take the square root. Well, you know what? There is no x value that I'm going to get a square root of negative 1, okay, because of that negative. So this one, I'm going to be honest, there's no value I can plug in for x in that denominator, and it would make it equal 0. So I don't even have to worry about that one. On this side, x squared minus 1 equals 0. It does not, we don't want it to equal 0, so x squared cannot equal 1. And when I take the square root of that, that means that x cannot equal plus or minus 1. Make sure you get both of them in there. Okay, so if I'm going to list the domain for number 1, I'm going to list all these domains in interval notation, and I'm trying to think of what x values can I plug in here. Well, the farthest left x value I can plug in is negative infinity. I can go all the way till I get to negative 1, cannot include negative 1, so I get a parenthesis. Then I can start back up from negative 1 to 1 and stop again at 1, no bracket because it can't equal 1. And then again, I can start up at 1 and go to positive infinity. Okay, so that's my full domain for number 1. Negative infinity to negative 1, in union with negative 1 to 1, in union with 1 to infinity. Okay, so the domain for number 1 there. Okay, number 2. I've got multiple fractions here, fractions within fractions. So my first one in this little fraction right here, I do not want 4 over x minus 2. Let me make sure I say this right. Let me start this one instead. I do not want my x minus 2, right, cannot equal 0. Well, if I added 2, x cannot equal 2. So that's one thing I can't have it equal as 2, because that would make that fraction by itself have a denominator of 0. Now, my second is my entire denominator right there, right? So I can't have 4 over x minus 2, that whole fraction. I do not want that to equal 3. Actually, let me write it this way, okay, so I don't lose you there. Minus 3, 4x minus 2 minus 3, I do not want that to equal 0, right? So I add 3. Make sure you follow where I got my 3 there. I add 3, and then I say, what could make this? So I would have to multiply by x minus 2 on both sides, right, to keep solving here. So I get 4 cannot equal 3 times x minus 2. Distribute the 3, right? 3x minus 6, add 6, divide by 3. I cannot have x equal to 10/3 because that would make that denominator equal 0 as well. So I really, to make sure we understand this, I had a tiny denominator, which says x can't equal 2. And then I have my full denominator, okay, my full denominator, which cannot equal 0. So I had two different denominators I was looking at there. Okay, so I get these two values that x cannot equal, the 2 and the 10/3, okay? So as we start my domain here, remember, I go from negative infinity to my first farthest left value. Well, which is smaller, 2 or 10/3? 2 is, so I'm going to stop at 2. In union with, I start back up at 2 and go to 10/3. And then in union with 10/3 to positive infinity. So there's my domain. Notice I'm skipping the 2 and the 10/3, okay? Please write these domains in interval notation. I know it actually looks like it takes longer, and it's longer than when you just used to write x cannot equal 2, x cannot equal 10/3, but we do want to write this in our interval notation. Okay. On to number 3. So, two things, two red flags: can't divide by 0, can't have a negative inside my my radicals, right? So, in my denominator, x minus 6 cannot equal 0. That takes care of my denominator. And then I also want the square root of x minus 3 needs to be greater than or equal to 0, right? Whatever's inside, and I should be careful there. I don't want the absolute value there. I want my value of x minus 3 to be greater than or equal to 0, because I need to keep everything inside my square root positive. Okay, so on the left, I add 6, x cannot equal 6. On the right, I add 3, it needs to be greater than or equal to 3. Okay, so farthest left value is 3, but I can equal 3, okay? So this is important. I can actually have my domain be a bracket there. I can start at 3, I can go all the way to 6. I don't want it to equal 6, so a parenthesis. In union with 6 to infinity. As I go larger than 3, I can keep going, okay? If it helps you to graph these on the number line and then write your intervals, that's fine, okay? I'll probably do number 4 that way because it has a new challenge to it. Okay, I have the square root of x minus 3 minus the square root of x plus 4. Okay, so what's underneath a radical cannot be negative, right? So my x minus 3 needs to be greater than or equal to 0. And my x plus 4 is also underneath the radical, needs to be greater than or equal to 0. So I get x is greater than or equal to 3. X is greater than or equal to negative 4. Okay? So think about this on your number line. I get a negative 4 over here. That's my smaller value. I get a 3. X needs to be greater than or equal to negative 4. So my bracket, and it goes to the right. X is greater than or equal to 3, goes to the right, okay? If you think about it, I need values that will work for everything, okay? So I need the intersection for my domain, okay? Not separate, because it needs to work for everything, which means I need it to work fine for both of them, the intersection. So my domain on this one is going to start at 3 and go to infinity, because that will fit both of those radicals. If I do anything in the negative, between negative 4 to 3, it's not going to fit on the one on the left, so I can't do that. So you have to go with the intersection, not the union of these domains, okay? All right, that's just domain. Let's move on now and start doing some composition of our functions. Okay, and I need to be careful. These are combinations of functions first, when I can add functions, subtract functions, multiply functions, and divide different functions, okay? These are combinations, and we work with them there. Now, as we work with domain and range here, depending on what we're doing, the domain of the one in union with the domain of the other, not union, intersection, okay? That our domains need to have the intersection of them. So if something's excluded from one, it has to be excluded from all when we do the combination, okay? So it is the intersection, what both of them agree with, okay? But we always have to be careful too, because when we do quotient, we could end up with new domains, okay? All right, let's just work through these. We're going to do all 4 of these operations for the functions f and g that I'm given here. To be honest, addition and multiplication Those are commutative properties, so you can do them in either order, but it is super important when we subtract and divide that we do them in the order in which they gave them to us. Okay, so first one we're going to do is f plus g, okay, and we're just going to add x minus 6 plus 5x squared. Is there anything we can join there, like terms? No, I'll write it in standard form, 5x squared plus x minus 6. What would my domain on this one be? Well, there's really no limits because I don't have any red flags. I don't have a denominator. I don't have anything with a radical, so I'm just negative infinity to infinity right there. Excuse me. Okay, next one. We're going to subtract them, f minus g. Order matters here. Make sure you have f first, x minus 6 minus 5x squared. Okay, again, no like terms, but if I write it in standard form, I get negative 5x squared plus x minus 6. And again, my domain, there's no limits, there's no red flags, so negative infinity to infinity. All right, f times g, okay? Meaning we're going to multiply together x minus 6 times 5x squared. Little distributing to go on there, so I'm going to distribute backwards basically, 5x cubed minus 30x squared. Okay. And remember, we're just joining them, finding like terms, whatever, so don't worry about GCF because we really just undid that, right? So you're just leaving it. This is it. And again, for my domain, I don't see any red flags, so I get negative infinity to infinity. Okay, the last one. And of course, I probably have no more room on my paper. Oh, I do. Okay, I lifted it just a bit. Okay, so let's try to see if we can get my f divided by g. Okay, so f divided by g, I put f on top, x minus 6 divided by 5x squared. Okay, can I do anything algebraically? No, I'm going to leave that. That is my f divided by g. What I need to be careful with my domain is I cannot let that denominator of 5x squared cannot equal 0. Well, solving for x, I get x squared. 0 divided by 5 is still 0. Take the square root. X cannot equal 0. Okay, so my domain, I go from my negative infinity to 0. Cannot include 0 in union with 0 to positive infinity for my domain. All right, first one done. It's pretty simple. Let's go to the next example. Okay, so you'll notice I have different functions. They look a little bit different. These are called rational functions. Let's just be glad we're not graphing a lot of those parent functions yet, but someday we'll get there. All right, here we go. First one we're going to do is f plus g. Okay, and actually let me take a step back and make sure I list my domains first. For f, my domain, I cannot equal 0, so I'm going to go negative infinity to 0 in union with 0 to infinity. Okay, struggling here. Union with 0 to infinity. And if I look at my g function, it's going to have the same domain. So when I go to combine these functions, I really am not going to change much in the domain because they share the same domain. Neither one of them can have 0 as the denominator. Okay, so f plus g. I'm going to have 2 plus 1 over x plus 1 over x. Well, because my x's have a common denominator there, I can add those and I can get 2 plus 2 over x. Okay, I could work to get a common denominator and put this over 1. I could multiply by x, and I could get 2x plus 2 all over x. Either way, it's fine, okay? My domain here, what can x not equal? Well, x still can't equal 0. So my domain on this one is going to be negative infinity to 0 in union with 0 to infinity. Okay. I can tell I'm going to regret my space here real quick. Okay, f minus g. I get 2 plus 1 over x. I'm going to subtract 1 over x. This actually is nice. These go away, and I'm left with 2. Okay? Which is great. That's my answer. 2 is my answer. However, be careful, because the domain does not come from your final answer all the time, though you always check to see if there's a new domain restriction, but it always goes back to your original. So even though my answer is 2, my domain here is still negative infinity to 0 in union with 0 to infinity. Even though I don't even have an x value left, I still have to start and use my original domains, okay? All right, let's do some multiplication. F times g. So I get 2 plus 1 over x times 1 over x. So that's going to give me, when I distribute, 2 over x plus 1 over x squared. Okay, you can go ahead and get a common denominator if you want, or you can leave it as is, okay? Either way is fine. If you get a common denominator, you'd multiply by x on both, so you'd get 2x over x squared plus that 1 over x squared. And again, no new restrictions on this domain. I do have x squared in the denominator, but that's the same domain basically as before, so I get the negative infinity to 0 in union with the 0 to infinity. All right, last one, f divided by g. So I get 2 plus 1 over x, all divided by 1 over x. It looks like almost a test question from chapter P. Put this over 1. Common denominator in the top, I get x, so I get 2x plus 1 over x, all over 1 over x. When I join the top, the numerator, I get 2x plus 1 over x. I'm going to take that, so keep the top, change to multiplication, flip the bottom, and my x's cancel. And I'm actually left with just 2x plus 1. There's my final answer when I divide. Okay, but once again, even though I have no denominator anymore, my domain has to be set at least with the restrictions I started with. Maybe it can be more restrictive, but it can't be less restrictive. So I still get the negative infinity to 0 in union with the 0 to infinity. Okay, so just always keep in mind that whatever your domains you start with are the first line of restrictions, and then something can actually become more restrictive, but you can never become less restrictive when you combine functions. All right, number 7 here. Let's start with just finding the domains of these. So the domain of the first one, f of x, I need to make sure x plus 6 is greater than or equal to 0. So x needs to be greater than or equal to negative 6. Okay, so that gives me a domain of negative infinity to negative 6, and then in union with 6 to infinity. Okay, on the g, x minus 3 needs to be greater than or equal to 0, which means x needs to be greater than or equal to 3, and I get negative infinity to 3 in union with 3 to infinity. Okay, on a side note, right now those are the two domains. They both have their own domain, but we have to think about, if we combine them, what is their restriction, right? So one of them was at negative 6, one of them was at 3, and I'm going greater than or equal to both of these, right? So where are they overlapping? So their domain of overlap would be, wow, really could have used you right there helping me catch my mistakes. Let me fix these domains. I can't start at negative infinity, right? It's greater than. So this one would be from negative 6 to infinity, right? And this one would be from, bracket, 3 to infinity. Okay, there we go. So if we think about it, the overlap, we would have to be the most restrictive, which is going to be 3 to infinity. So just keep that in mind, that that's going to probably be our most common domain used here. Okay, so we've only worked with domain yet. We haven't even started our operations. So f plus g. So I'm going to get square root of x plus 6 plus the square root of x minus 3. Is there anything I can do to join those? No. That's it. That's the addition. What's my domain? Well, it has to be the most restrictive, which is going to be the 3 to infinity. Okay. So f minus g is going to be square root of x plus 6 minus the square root of x minus 3. Again, there's nothing I can do to join those, and my domain, again, is the most restrictive, which is 3 to infinity. If I multiply f times g, I get the square root of x plus 6 times the square root of x minus 3. My rule for multiplying square roots together is I'm allowed to multiply what's inside them together. So I can actually join these. When I do that, I would FOIL, right? And I'd get like x squared plus, let me see, I get a plus 6x, a minus 3x, so that gives me a plus 3x minus 18. Okay, so that is what we get when we multiply them together. I need to have that greater than or equal to 0. Well, again, that's going to go back to my original restriction, so I'm going to have that same domain of 3 to infinity. Okay, anything smaller than 3, and I could get a negative in there. All right, last one, f divided by g. I get the square root of x plus 6 divided by the square root of x minus 3. Okay, so just a quick reminder on these domains. The big difference on this bottom one here, we already did x minus 3 up here and said it was 3 to infinity. The big difference now is we were allowed, when it was not in the denominator, to have a square root of 0. But because it's now in the denominator, I can't have it equal to 0. So the big difference is now x needs to be greater than 3. It cannot be equal to 3. And so what that will change for my domain is I'm going to be parentheses with 3 to infinity because I can't actually equal the 3. Other than that, it stays the same. Now, quick note, I realize I did not rationalize that. I'm not going to. I'm going to leave it. It's more just to kind of keep it in your mind how the domain changed on that, okay? If I want you to rationalize, I will give you a directive in a test or quiz that says, please rationalize this. But for right now, we're just going to leave it. All right, composition of functions. Okay, this is slightly different than the combination. Combination, we do an operation, add, subtract, multiply, or divide. Composition is we're going to do one within the other, okay, is kind of what we're doing. So composition of the function of f with g is denoted f of g. Okay, we often say it f of g, that little tiny circle of the of word, okay? And another way to write it, and we need to be fluent in writing it either or, and if I switch it, you need to know what it says. So with the dot in between is the same thing as saying f of g of x over here, where the one closest to x is inside and you work your way out. Okay, so what, if you remember composition of functions, it means do the operation to the inside, get your answer, and then take that answer and plug it into the next function, okay? Now, this is where we really have to be careful. The domain of a composite function is the set where what can x be in g, in the inside one, and then what is g's restriction for the domain of f. It always is about the inside function, not the combination of the functions. So when you're doing a composition of functions, it's always about the inside function's domain. And that's going to be our key on this. We've got to stay and think about the inside one, okay? So a couple different things we're going to go through here. We're going to do, and just to show you there is a difference depending on the order they give you the composition of. So the first one, f of g of x, then we're going to flip it on b for g of f of x, and finally we're going to actually do one with a value, find f of g of 3, okay? So one at a time here. I'm going to do f of g of x to start with. Looks like fog, doesn't it? Okay. The other way you can write this is f of g of x, okay? And you can see right away why it might be beneficial for me to write it that way right now so that you can actually read it so it doesn't look like fog. Okay. That means I'm going to start with g of x, and I'm going to plug it into every x in f, okay? So when I see f of g of x, that means inside for this x right here, I'm going to plug my g of x. So negative x squared plus 4x minus 1. Okay, so I plugged in that for x. And don't forget, I still have this minus 2 on the outside because all I did was replace my x with my entire g of x. All right, simplifying. Negative 5x squared plus 20x minus 5 minus 2. That simplifies to 15x. No, I'm sorry, those two do not join. This is where I really could use you guys keeping me in line. Negative 5x squared plus 20x minus 7. I think that's the best we can do. Okay, so we start with the domain. When I look at this, there's no red flags, but I always go back to my inside function. And I look at g of x and I say, are there any domain restrictions on g of x? I don't see any, so that means for my full thing, I can just be negative infinity to infinity. Nothing's restricting me at all right there. Okay? Now, what's the difference between f of g of x and g of f of x, right? So g of f of x, right? Again, I'm not doing much better with my writing, so I'm going to write it g of f of x. This time I'm going to plug in all of my f of x into every x in g. So g gets a negative, and I'm going to plug in my f of x, 5x minus 2 squared plus 4 times 5x minus 2 minus 1. So I'm plugging in all of my f of x everywhere I see an x in the g function. All right, I've got some foiling to do here. So that's going to be a negative on the outside. I'm going to get 25x squared. I get two negative 10x's in the middle to make negative 20x plus 4. Distribute my 4 here. I get 20x minus 8 minus 1. I need to distribute my negative all the way through. So I get negative 25x squared plus 20x minus 4 plus 20x minus, if you're okay with this, I'm going to just join those and make it minus 9. All right, one more time of combining like terms. Negative 25x squared plus 40x minus 13. And there is my g of f of x. Okay, so I started on the inside, worked my way to the outside. Once again, so I look at my f of x this time because that is where my inside number, my inside value is what's going to set my domain. F of x had no restrictions on it, so that doesn't carry anything through. When I get my final answer here, it has no restrictions on it, so it looks like my domain can stay negative infinity to infinity. Okay? All right, for C, f of g of 3, okay? I'm going to cheat a little bit here, especially because I'm out of space, but when I do f of g of 3, that's really the same thing as saying if I come over here to my f of g of x, now replacing all my x with 3 instead of that. So I can basically come over here to what I have here, my final answer, and just plug in 3 for my x, and I get negative 5 times 3 squared plus 20 times 3 minus 7. So 3 squared is 9, and minus times negative 5 is negative 45, plus a 60. That gives me positive 15 minus 7. I think I get it 8. Okay. Now, I took the work we already did, and I plugged into that and got the 8. The other option is you plug in your 3 into G. Okay. I'm just going to come up here and do it so you can see this same thing. So I start by plugging 3 into every x of g, so I get negative 3 squared plus 4 times 3 minus 1. Okay, so I'm only doing g of 3 right now to start with. That's negative 9 plus 12 minus 1. So g of 3, I get an answer of 2. So now I can replace all of my g of 3 with the number 2 and get f of 2. And I can do 5 times 2 minus 2, so I get 10 minus 2, which is 8. So did I get the same answer both ways? Definitely. So it's just a matter of if you want to use previous work or start over with a value. Either way is fine. Okay. I think part of my problem here is running out of paper, so I'm hoping I'm not confusing you too much there. Let's look at page 3. Okay. We're doing one more of these combinations, okay? So we're going to do the f of g of x, the g of f of x, and then the f of g of 3. Okay, so the same thing we just started with on the last one. Let's see if I can make this a little bit more condensed. Okay. So the first one we're going to do is f of g of x. Okay, so I'm going to take my g of x and plug it in for f of x. So in for my x and f of x, I'm plugging in my g of x. Okay. Back from chapter P, that means I keep, change, flip. Which looks like my 3's are going to cancel and I'm left with x. Okay, so my f of g of x is x. Okay, I need to take a step back though and remind myself what was my inside values domain. So I'm looking at g of x. What was g of x's domain? Well, I can't equal 0, so this domain here was negative infinity to 0. In union with 0 to infinity. And just like when we combined earlier, even though when I do f of g of x, I see no more restrictions and I see no red flags there, I have to go with the inside values domain. So I'm going to have to include that restriction from earlier, negative infinity to 0 in union with 0 to infinity. So you have to go back to that, okay? All right, so let's do g of f of x. So now I'm going to plug in the f into my g. Well, seeing how these are the same, it's obvious we're going to get exactly the same thing again, right? So this one is also going to restrict and go to x, but once again, I go to f's restrictions, which they have the same restrictions since they were the same function. So once again, this one is going to get me a domain of negative infinity to 0 in union with 0 to infinity. And that was for the g of f of x as well. Okay. Last one, let's do g of f of 3, or I'm sorry, f of g of 3. Okay, so that means I'm going to start on the inside. I like to write them this way, I'm going to be honest. I'm going to start on the inside, do g of 3. So g of 3 is going to be 3 over 3, which is 1. So g of 3 equals 1. So now I'm going to do f, and instead of g of 3, I'm going to plug in 1. So I get 3 over 1, and that equals 3. So my f of g of 3 equals 3. Okay? And again, I could have come over to this original over here, because that was f of g of x, and just replace my x with 3, and I would still have the same answer. Okay? Okay. So excluding values from the domain of f of g of x, and again, everything is coming from the inside and we work our way out, okay? So if you start in with f of g, and the g, whatever's the closest, is going to be the restrictive domain, okay? So before we do f of g, let's just talk about domains in general here. On number 10 for function f, x plus 1 cannot equal 0. Which means x cannot equal negative 1. Okay, so on g, x cannot equal 0. Okay, so those are my restrictions. Because I'm going to do f of g of x, okay, it is only going to be the g that matters, okay? I don't worry about this one because it's only the one inside the closest to x that actually matters, okay? So my domain on this one, before I even start, is going to be negative infinity to 0 in union with 0 to infinity, okay? It's always about the one on the inside. All right, so let's do, I'm plugging g of x into everywhere of x for f of x. So I get 4 over x in my first x over 4 over x plus 1. So fractions within fractions, right? We let one big fraction in my numerator. I only have one. I need to get the denominator to one fraction, so I multiply by x. I get 4 over x plus x over x. Join those up. I get 4 plus x all over x. All right, I want to change one fraction into, or one huge fraction into, not have so many fractions, right? So it's the numerator, which is 4 over x, times the reciprocal of the other one, x over 4 plus x. Keep change flip. My x's cancel. I'm left with 4 over 4 plus x. Okay, so here is my composition, right? I did f of g of x. This is my f of g of x. And now when I go to do the domain, my domain has to start with what I started with for g of x. So that's my negative infinity to 0, 0 to infinity. But also look at my new function and see if there's any new restrictions on it. So with this new one, 4 plus x cannot equal 0. So x cannot equal negative 4. So my new domain, I need to use this new restriction with my old restrictions. So I'm going to go from negative infinity. The first value I'll get to is negative 4. in union with -4 to 0, in union with 0 to infinity. So it added another restriction into that domain. All right, let's try this next one with a square root function. My square root function would say I'd need to stay from 0 to positive, right? But that's my f. For my g of x right now, it's from -infinity to infinity. So as long as I'm doing f of g of x, okay, I'm looking at only the inside's restriction. So right now, I can use anything I want for my domain, okay? Now let's do the composition. So that means I'm going to put my g of x everywhere I see x in my f of x. There's my function. I can't do anything with it. So there is my function. To find my domain, I need to look at my g restrictions, which was none. Now my new restrictions would say x minus 5 needs to be greater than or equal to 0. So x needs to be greater than or equal to 5. So combining this restriction with my old one, which there was none, I now need to be 5 to infinity to be my domain, okay? And remember, I can equal 5, but I just can't go lower than 5 because I would be in the negatives, okay? So the inside is what's going to control our domain, and then anything new from our final answer. All right, last page, and there's really not a much here. Decomposing functions. When you form a composition function, you compose two functions to form a new function. So it's also possible to reverse the process or decompose a given function and express it as a composition of two functions. Okay, key thing right here, okay? And this is so important to know. Answers can vary. There is no like one set of answers here, okay? So make sure you know this. There's no one set. You just need to do this, okay? So let me give you a couple ideas. So what this is saying is that we've already combined two functions and we were left with that. So what were my two functions, okay? Well, let's just keep this honest. Maybe I have something in the denominator, so I'm going to call my f of x 1 over x, so that gives me a denominator. So if that's the case, my g of x that I had to plug into that, well, in for this denominator, I need it to equal 2x minus 3, okay? So I could call my g of x 2x minus 3. When I plug it in for x into f of x, I get 1 over 2x minus 3. That's one way to look at it, okay? So that would be an answer. I could get maybe a little more on my f of x. Maybe I call my f of x 1 over x minus 3. If that's the case, I need my g of x that I plug in to be 2x so that when I plug into this x spot, I get the 2x where it needs to be, okay? The thing is, you could get some really complicated things here. You don't have to. I would say if you decompose, keep it simple, okay? This first one is probably the easiest thing to do. Just look at the general overall, what kind of function do we see, that 1 over something, and then get more specific on the second one, okay, to get where you need to be. Okay, practice. Page 229, 3 through 78 by 3s, do the odds, go to Slater to see answers. Just do some practice so you feel good on the decomposing. We're not going to have as much of that, but composition of functions, the combination of them, and I can't stress enough making sure you understand domain, okay? Make sure you understand where the restrictions in the domain come and when you need to use both domain restrictions with the combinations and when you only use the inside domain with the resulting domain for your composite functions, okay? Let me know if you have questions.